We are picking up in lesson 6.2 again today. Remember yesterday, we learned this compound interest formula right here, right? We worked on filling in our principal, our interest rate, our the number of compounding periods per year, and we looked at time, okay? And we did those examples. And I said today we're going to learn a different formula. And this is if a situation is compounding continuously. Okay, so when we talk about continuously compound interest, it uses a formula with the natural base E to calculate and add back accumulated interest at the smallest possible intervals. So I think maybe the smallest interval we did yesterday was monthly, where interest would compound once a month, okay? I think I saw an example in homework that was daily. Okay, that's about the smallest I've seen that you use the compound interest for. Okay, continuous is just continuously happening. Now, the formula we're going to use is A equals P times E to the RT. Hurt. Are you familiar with that, or that's just immediately what you said because that's what it looks like?
Yeah.
Okay, so yes, PERT. Now, E. Are we familiar with E?
Oh my gosh.
Are we familiar with E?
Exponent.
No. Okay. E is a number. Kind of like, okay, you guys are familiar with pi, yes? Pi is a number. Okay, it's a big, long, irrational decimal. It goes on forever and ever, yes? E is the same thing. It is a big, long, messy decimal. It goes on forever and ever. Okay, it's also a button on the calculator that we'll talk about. Okay, but E is 2.718, yada, yada, yada. Okay? Now, that's what we're going to use here. P is still your principal invested. E is just the natural base, the number. R is still your annual interest rate, written as a decimal. A is still the value of the account after T years. So let's look at our first example here. Regina invests $12,600 in an account that earns 3.2% annual interest, compounded continuously. What is the value of the account after 12 years? So, go through. What can you tell me here? What do we know?
12,600 is
Okay. $12,600 is going to be your money you're starting off with, so that is your principal. What else do I know?
T is 12. Your 3.2 is.
Okay, so two things there. Annual interest, your R is the 3.2%, but we're not using it as 3.2%. Move the decimal 2 places left, and we'll use it as what?
3. Yeah.
0.032. Okay. 12 years, that is your T. And what's the key word here? Compounded how? Continuously. That means I don't have an end value. That means that I'm going to use, when I see the word compounded continuously, that tells me I'm going to use PERT. Okay? That's exactly what it tells you, is that's the formula we're going to use. So, let's try this out. A equals P times E to the RT. We're trying to find A. We know P is going to be 12,600 times E, which stays E, to the 0.032, which is your R, times E, which is 12. Now, like yesterday, there are right ways and wrong ways to do this on the calculator. My encouragement is going to be that you go ahead and multiply your exponent. Not saying you have to, but that's going to be my suggestion. So then it's 12,600 times E to the, what exponent do we now have? Zero point 384. Okay. From here, It is a plug everything in the calculator. Okay. I would just start by going ahead and doing the 12,600. You can take times, you don't even have to use the times button. Now, E. Did you find a location for E on your calculator?
Yes.
Yeah.
Okay, it's going to be there somewhere. On these particular calculators, you see E to the X on my calculator right above my LN button. So for me, it is the second function of the LN button. So if I do second and the LN button, notice it pops up an E. Okay, now, on my calculator, it pops up an E with a parenthesis already there. So actually, if I hadn't already multiplied, I'd be okay. And you can put in the 0.384. You can enter your parenthesis or not enter your parenthesis. And I forgot it pops up the parentheses. So you could actually just put it in as the 0.032 times 12 and be okay too. Does your answer match my answer?
Yeah.
If you have a different calculator from me, did you find E? It's there somewhere. It's on any scientific calculator. Okay? So if you can't find E, let me know and I'll help you find E. But how would you express this answer?
100. Nope. 1,000. Nope.
18,498.63 cents.
I sound like good big numbers. What can I say?
Hey, you corrected yourself every time. You started and nope, you realized. So $18,498.63. Okay. Did we get the calculators to do what we needed them to do?
Yes.
Okay. So this is another formula to put into our repertoire of things. Okay. You see the word continuous? No? Okay, this is the formula I'm going to use. Okay, let's go to the top of the back page. And we're going to practice a little bit more before we move to the final section. Example B, you invest $125,000 in an account that earns 4.75% annual interest compounded continuously. What is the value of the account after 15 years and then after 30 years? Okay, what do you know? $125,000 is your principal, your P. 4.75% is R. How are we going to express that?
Left. 0.0475.
Okay. 0.0475 when you move that decimal 2 places left. Compounded continuously?
That's
That just says I'm using P times E to the RT.
and then 15 is T.
And then in the first part, 15 years, so we're using that as T. Okay. A equals P times E to the RT. Practice. P is 125,000 times E to the 0.0475 times 15. Okay. You honestly could, depending on your calculator, the way my calculator came up, it gave that parenthesis on the exponent. So you honestly could just type it in right here. Okay, you really could. If you want to do that cleanup step, it's 125,000 times E to the whatever 15 times 0.0475 is. Which I have 0.7125.
$25,000.
Nope. 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 Reagan.
Stop! I'm trying. 4,000.
885. You almost got it, yes.
Nothing I did.
You get a big number, yes? If I just write this down, what do we have? 2, 5, 4, 8, 8, 5, point,
That looks like a phone number.
point what?
32.
3, 2. Now, my thing is, I'm going to go back and count 1, 2, 3, comma, which I know you can't do on the calculator, and so then I'm at $254,885.32. What changes on the second part?
30 years instead of 15.
Okay, 30 years instead of 15. Now's a good time to play around with the calculator, right? If you want to see, okay, could I enter it this way? Could I do it this way? Now's a good time to figure that out. Well, you have an answer to check against, right? So this time it's still 125,000. E to the 0.0475. Instead of times 15, I'm going to do times 30. Okay? You could enter it like this if you want. If you clean it up, 125,000 times e to the 1.425. Does your big answer match my big answer?
519,732 and 23 cents.
There we go.
Oh, I said the number right.
You're gonna be thankful.
Yes.
Okay, guys. Pay attention when you're doing the interest. Is it compounded monthly, quarterly, annually, semi-annually? How is it compounded? So where you use the formula from yesterday, or is it compounded continuously? And we're going to use the formula that has the E in it. Everyone's good with the calculators and whatnot, right? Okay. We've got one last topic to address. Okay. And I think I can go on to the next screen here. Yeah, I have it on the next screen. We're going to talk about how to write an equation in exponent form when you're given 2 points. Okay, like back in the basics of Algebra 1. If you're given 2 points, we talk about how to write the equation of a line, where you have to find the slope and you have to find the y-intercept. Okay, here we're going to talk, okay, given 2 points, how can we write an exponential equation? So, when data points have consecutive x values, you guys know the word consecutive?
One after the other.
Yeah, two things are consecutive, they're right after another, right? So 3, 4, 5 are consecutive numbers. Okay, so when data points have consecutive x values, the growth factor b is the ratio of their y values. Okay, so in order to find b, we're going to be doing the ratio of the y values. Once we have b, we're going to use the value of b and one of the points to find a. Okay, and that's going to be kind of our process. Now, depending on the problem, it could get a little messy. You're going to need to have your calculator in front of you again, and we'll talk about ways to use the calculator. Okay, so example A. Tia knew that the number of emails she sent was growing exponentially. She generated a record of the number of emails she sent each year since 2009. In 2015, she sent 1,000 emails, and in 2016, she sent 1,400 emails. What is an exponential model that describes the data?
She's a 51 more.
That is a lot of emails.
I think I sent maybe one email a year.
Well, let's look at her exponential model. Okay, so first of all, now, I feel like more the ones you're going to see in homework, no, not always, but they'll often just go ahead and give you the ordered pairs. Did they give me the ordered pairs here? No, they didn't give me the ordered pairs. So we're going to talk about the ordered pairs here. What 2 years do we have information for?
15 and 16.
We have information for 2015 and 2016. Now,
Consecutive.
with that in mind, what do we know about 2015? In 2015, she sent 1,000 emails. In 2016, she sent
1,400.
1,400 emails. Okay? Now, I want an ordered pair to represent this. Now, the one thing I will say, okay, you kind of, in a way, see the ordered pairs creating themselves, yes? Except we're going to tweak it a little bit. In 2015, there's 1,000 emails. In 2016, there's 1,400 emails. However, we're not going to use 2015 and 2016. What's our reference? What's our year zero, so to speak?
2014.
No.
2009.
Each year since 2009. So when we talk about what our X value is, okay, because they are consecutive years, we're going to talk about years since 2009. Okay. So just so you realize that. So 2015 is how many years since 2009?
Like 6.
Like 6. So 6 years since 2009, and how many emails did she send that year?
1,000.
1,000. So one of our ordered pairs is going to be 6, 1,000. What about the year 2016? How many years is that since 2009?
7.
7. And 7 years since 2009, how many emails did she send? 1,400 or 1,400. So those are the two ordered pairs we're going to use. Okay? Those are the ordered pairs we're using. Now, how did it say to find B? B is the ratio of the Y values to find B. What are my Y values?
1,000 and 1,400.
Okay, so those are my Y values, keeping that in mind, right? So B is the ratio of those values. Now, when we talk about the ratio of those values, we're going to do the latter year over the more recent, or I'm saying that weird. We're going to do 1,400 over 1,000. So you're going to do, it's not necessarily bigger Y value over smaller Y value, but it's in terms of comparing it with from the X values. Why can I not put this in easy words today? When we do our B, okay, I'm using 1,400 divided by 1,000. Because I'm going with, on top is going to be the one paired with the larger X divided by the one paired with the smaller X. Is that did I finally get it? Make a little sense? Sorry, I'm tongue-tied today. Now, with B, it's 1,400 over 1,000. Can we reduce that? What's that going to reduce to? What's an easy reducing? What could cancel here?
1,000.
Yeah. Can the zeros cancel? The zeros cancel, zeros cancel. So we have 14 over 10, if you will. What do you know about 14 over 10? They both divide by 2, and you could say 7 over 5. Or is it a nice decimal in this particular case? What is 7 divided by 5?
1.4.
1.4. So in this case, is it a nice easy decimal?
Yeah.
It is. So right there, your B value can be expressed as 7/5 or 1.4. I will let you use either or. I really don't remember how Savas wanted you to input your answer. If they had a preference. Okay, so we found B. Now, after you find B, what did it say? Use the value of B and one of the data points, so one of your ordered pairs, to find A. So keep in mind, the basic equation is y equals A times B to the X, yes? Fill in an ordered pair and fill in your B value. Which ordered pair do we want to use? I'd probably use 6, 1000. What do we know in an ordered pair? It's X, Y, right? So Y equals, I'm going to say 1000 equals, A is what we're trying to find, times B. You guys want to use the easy version, B? 1.4 raised to the X. What is X in this scenario? 6. Okay. Before I delve into the calculator, how do I find A, just generally speaking? If it's A times 1.4 to the 6th, how are you going to get A by itself? If it's A times something, we're going to need to, what's the opposite of timesing?
Dividing.
Dividing. So I'm not going to put this into my calculator yet because it might give me an awkward, yucky decimal. I'm just going to go ahead and say, okay, I'm going to divide by 1.4 to the 6th. If I divide one side by 1.4 to the 6th, guess what? I'm going to divide the other side by 1.4 to the 6th. You could have parentheses here, you could not. And put it in your calculator. Give me an answer. $1,000 divided by, and you should just be able to do 1.4 raised to the 6th. Now I'm looking at what I have in my notes versus when I worked through the homework. Okay. Are you guys getting what I'm getting? Okay. In my notes, I have 1 decimal place. But it looks like in the homework, they were maybe doing 3 decimal places. Okay. Here's what I'm going to say. Watch the directions on homework, right? So if I do 3 decimal places, this is what? 132.810. And what did we just find? That is our A value. Okay? We found A. We found B. What was our directions? Our directions is to write an exponential model. So our directions are to write the y equals A times B to the X. So we're going to fill in A and B. We're going to say y equals A, which is 132.810, times B, which is 1.4 raised to the X. And that's the final answer you'd be looking at. Okay? You have to fill in the A and the B. Watch your rounding directions. Questions here. Do we somewhat follow that? Did our calculators cooperate? Are we ready to try the next example? Okay. Word problems, they're not always going to give us the ordered pair. We're going to have to set them up sometimes. But you'll also see problems where they just give you the ordered pair, which is nice too. Okay, let's try B then if you're ready. A surveyor determined the value of an area of land over a period of several years since 1950. The land was worth $31,000 in 1954 and $35,000 in 1955. Use the data to determine an exponential model that describes the value of the land. Do I have consecutive information here? Did they give me back-to-back years of data?
Yeah.
Yeah, they gave me 1954 and 1955, yes. So let's write down what we know. Or just jump right in. In 1954, the value of the land was $31,000. In 1955, the value of the land was $35,000, right? Thoughts on what these ordered pairs are going to be?
4, 31,000 and 5, 35,000.
I like them. 4, 31,000 and 5, 35,000. Why did she use 4 and 5? They gave us kind of a year zero, so to speak, of 1950. So right here, this is going to be years since 1950. Okay? And it's not that you couldn't use those values, but it just makes life so much easier if you use these smaller values of 4 and 5. Okay, look back to your previous problem. Once you have your ordered pairs to look at, first thing we need to do is we need to find B. How am I going to find B? Look back up to your previous example.
35,000 over 31,000.
Yeah, 35,000 over 31,000. It's the ratio of the Y values. So 35,000 divided by 31,000. Now, the math person in me says, oh, there's 3 zeros at the end of each number. Can I at least cut those off and make these numbers easier to work with? I can. Not saying you have to. Now, 35 over 31 doesn't reduce any farther. What kind of decimal do you get? But it keeps going past that, doesn't it? I have written down my notes 1.129 ... Because, and here's what I'm going to warn you guys. If you go and just use 1. For instance, 13, you could get yourself in trouble on your final answer. Okay? You need to use as much of that decimal as you can. Don't round it too soon. And so, like, for instance, if we're going to give our answer with 3 decimal places, you've got to leave, I would say, at least 4 decimal places to get going. Now, I'm going to show you a different option. Here's my thing. Well, B is that decimal. My recommendation on what to use for B, I'm going to suggest we just use the fraction form. Okay? That's going to be easiest if you ask me. Might look not fun, but it's going to give us the best answer. Okay. Now we found B. Now we need to find A. Remember, we're using that form, y equals a times b to the x. Which ordered pair do you want to use? Doesn't matter. No. You want to use the one with the 4? Works for me. It doesn't matter, though. Okay, so if we use the one with the 4, the y value is what?
31,000.
The 31,000, right? XY. So we're going to do 31,000 equals A, which I'm trying to find, times B, which I'm going to use 35 over 31, raised to the X, which is 4. Okay. This is where the calculator is going to come in handy. Now, think with me. How do I get A by itself? We divide, right? If it's A times this thing, we're going to divide by this thing. So I'm going to divide by 35 over 31 raised to the 4th. What I do to one side, we're going to do to the other side. Okay. Now, you can figure out already, A is not going to come out a pretty answer. Now, I can't stress enough, practice the calculator with me here. 31,000 divided by. Here's my suggestion, is that you do parentheses 35 over 31 in parentheses raised to the 4th. And this should be your A value, 19,078.15144. Did you get that A value? Then you used your calculator appropriately. Okay? Where I hesitate, if I had done 31,000 divided by, say, 1.129 raised to the 4th, I want to see if it would have worked. Notice it throws my answer off there, doesn't it? Okay, and that's why I encourage you to not just use a rounded decimal, but to use the fraction. $19,078 by say 0.151 for 3 decimal places. Okay, that's your A value, yes? And this is what I was I'm trying to look and see, and remember, how did Savas want answers? I think Savas actually wanted 3 decimal places. So I'm going to give you 2 options of how to write this, but I think Savas is going to want the decimals. One option is to say A times B to the X, right? So 19,078.151 times B to the X. So personally, if it was me, I would say B was 35 over 31 raised to the X. However, I don't know that Savas wants a fraction there. I'm going to put it right below it. So the other option would be y equals 19,078.151 times, what was our B decimal from before? 1.129 raised to the X. Looking at my notes, it looks like I did more decimals. And I think that's what Savas wanted. Now, for me personally, these are both good answers. For Savas, read the little part down in parentheses after the problem that tells you how they want their answer. Okay? Questions there? Now, I feel like I saved the easiest problem for last. Write an exponential model given the 2 points 3, 5, and 4, 10. Why is this one easier?
They're giving you the ordered pairs.
The ordered pairs are there, folks. The process is no different than the last 2 problems. We just don't have to set up the ordered pairs. So 3, 5, and 4, 10. Did they give me consecutive data points? They did, 3, 4. So we're going to start off by finding B. How do we find B? B is going to be 1 over what?
10 over 5.
Okay. It's going to be your y values.
2.
So 10 over 5. And even this, it even comes out to be a whole number. Oh my goodness. B is 2. Okay. Y equals a times b to the x. How do you find a?
You 10. No. You would plug it in. 5 equals a times 2 to the third.
Okay, is that one way to do it? She used the ordered pair 3, 5. Okay, and plugged in the b value of 2. And do some math. I personally know 2 to the third is 8. So if you want to go ahead and do that math right here, you can. 2 to the third is 8, so this is 8a. I know we have it on the others, but that's math I know. How do you get a by itself?
You divide.
Yeah, we're going to divide by the 8. And you can tell me that a is 5/8, or as a decimal it is that 0.625? Yeah. So a could be given in either form. And can you write your final answer? Y equals a times b to the x, so you could say 5/8 times 2 to the x, or 0.625 times 2 to the x. And you can put parentheses around the 2, you don't necessarily have to. Although I think it worked better in Savas if you use the parentheses. So. Okay, guys. Those are the 3 different types of problems you're looking at in homework. Okay? Can't remember, you either have 10 or 12 problems. I think it might be 12. So, make sure you guys get that done for tomorrow.